All right, good morning. We get to start Pythagorean Theorem today. We're going to actually spend 3 days on Pythagorean Theorem because I don't want to teach something else before spring break. So we'll just do 3 days Pythagorean Theorem. So the test over this is on April 8th. We've got spring break, virtual day, April 1st, April Fool's Day. That'd be pretty funny if they were like, April Fools, you have to come to school. But
April 1st is my dog's birthday.
Oh, it is? No school on Good Friday, April 2nd. No school Good Friday. Okay, so today we're going to start talking about Pythagorean Theorem. Have you guys heard of a squared plus b squared equals c squared? Yeah. And then just a quick reminder, what if I had like x squared equals 144? What would I do to solve that? You square root it. Square root it. Is everybody good with that? You have to square root to get what x is. Stop. Okay, let's talk about the Pythagorean Theorem. So we have a right triangle. The side across from the right angle is called the hypotenuse. Did you guys know that? Yes. It's always the longest side. So the side across from the right angle is the hypotenuse, and it is the longest side of your right triangle. So most of the time we hear it as a squared plus b squared equals c squared. But today I'm going to write it as c squared first. C squared equals a squared plus b squared, and you're going to see why in a minute. But something that I want to talk about is just like when we had x squared equals 144, and you have to square root that. We don't want what c squared is. We're going to want to solve for c. So would you agree that if we just square root a squared plus b squared, then we would get c?
Yeah.
Because the square root of c squared is c. Okay, so keep that in mind. Okay, so sides A and B, doesn't matter which side's A, which side's B, doesn't matter. C has to be the hypotenuse, the longest side. Okay, so if we know A and B and we don't know C, to find C, it's c squared equals a squared plus b squared, but remember, we would just square root, so c would actually be the square root of a squared plus b squared. But what if I had to find A or B? If I already know the hypotenuse, so if you already know the hypotenuse, let's pretend like it's 5 and this is 3 and I have to find B. So if I had a squared plus b squared equals c squared, do you guys agree that I would just need to minus on both sides to get the b? Like algebra, you guys okay? Okay. And then I'd have b squared equals 5 squared minus 3 squared, and then if I just square root that, I would get my answer. So, if you know the longest side, you're going to subtract to find the one of the shorter sides. So say I know a and c, to find b squared just equals c squared minus a squared. It's very important that you always subtract the biggest side because you can't have a negative under the square root. Can't have a negative. So really just to get b, I would do the square root of c squared minus a squared. And say I know b and c and I need to find a, same concept, that a would really equal the square root of c squared minus b squared. Okay, let's try some problems. You guys got your calculators ready? Okay, let's look at this. So notice I do not know the hypotenuse. Does everybody see that? Yeah. That's the longest side. I need to find the longest side. So I'm going to add under the square root. So x squared would really equal 16 squared plus 30 squared, but I have to square root that. Okay? So in your calculator, you can just do the square root. You guys know how to do that? Second x squared. What were the numbers? 16 and 30? Yeah. 16 squared. Do you know how to get the little 2 there? Mm-hmm. Just hit that x squared button. 16 squared plus 30 squared. Hit enter. And our answer is 34. So that means that that side length is 34. So it's just a squared plus b squared equals c squared. You could write it out the longest way, I guess. 16 squared plus 30 squared equals c squared. Figure out what 16 squared is, figure out what 30 squared is, and then take the square root, but this takes less time. So if you don't know the hypotenuse, you have to add. You need a bigger side, so I want you to add. But say you do know the hypotenuse. If you do know the hypotenuse, do you guys all agree hypotenuse is the longest side?
Yeah.
So if you know the hypotenuse is the longest side, you need a shorter side, so you're going to have to subtract under the square root. Now, if you subtract under the square root, you have to take the bigger number minus the smaller number. So I would have to do 25 squared minus 24 squared. I already know that answer
1 squared.
in my head. What is it?
1 squared.
No.
It's 7.
7?
7. 25 squared, you can't do 25 minus 24.
Oh.
You have to do 25 squared minus 24 squared. Did everybody get 7?
No.
So in your calculator, square root 25 squared minus 24 squared equals 7. Okay, let's look at this one. Do I know the hypotenuse?
Yeah.
Would I add or subtract?
Subtract.
Subtract. We need a smaller side, so you have to subtract. So I'm going to do 18 squared minus 15 squared. So square root 18 squared minus 15 squared.
9.949.
3 radical 11. Some of your answers you can leave like that, like if it's a multiple choice. But if you need to change it to a decimal, do you guys remember how to change it?
No.
The toggle button right above the enter. So you push that button, changes to a decimal. You push it again, changes it back to a radical toggle. So 9.9. 9.9. All right, do I know the hypotenuse?
No.
So do I add or subtract? Add. We want a bigger number, so you add 5 squared plus 4 squared. 5 squared plus 4 squared. Hit enter, radical 41 or
6.4.
6.4. Okay, how do you guys feel so far about the Pythagorean theorem? If you need the bigger side, you add. We need to find the hypotenuse, add. We need the biggest side. If you already know the hypotenuse, subtract because we need to find a smaller side. Okay, let's talk about a Pythagorean triple. These are my favorite. I love the triples. All the triples do is just saves you time. So if you don't memorize the triples, it's okay. You can always do the Pythagorean theorem. But when you take the state test, or when you take the test like the ACT test or the SAT test, a lot of times they give you triples, but then they take the question further. So they make the question a lot harder. It's not just going to be plain Pythagorean theorem. If you know the triples, it's just going to save you time, and those tests are timed tests. So a Pythagorean triple is a set of non-zero whole numbers, no decimals, whole numbers that satisfy the equation a squared plus b squared equals c squared. So some common triples is like the 3, 4, 5. Or like a second ago when we had 24 and 25 and I already knew that that other side was 7, it's because I know that triple is 7, 24, 25. So I just looked at it and was like, oh, I already know that that's 7 without having to do the math. So these are the most common triples. You will see these on your test. So I've got the 3, 4, 5, or multiples of those. You might see a triangle that this says 30 and 40, and I say to myself, oh, that's a 3, 4, 5. The hypotenuse would have to be 50. Another common one is the 5, 12, 13, or multiples of those. 8, 15, 17, and 7, 24, 25. I have them on the board too. So they're just common triples. The thing is, the order matters. So like, for example, if I have like 5 and 3, why could the hypotenuse not be 4? It's not the longest side. That 5 has to be on the hypotenuse for that to work. And then I would know it's a 3, 4, 5 because the biggest side has to be. Otherwise, you have to do the Pythagorean theorem. So let's look at a couple more. Let's look at this one. So this is a something 12, 13. Do you remember?
5.
5, 12, 13. It's up here. So instead of having to do the Pythagorean theorem, if I remember 5, 12, 13, I can be like, oh, that's 5. I don't have to do any work. If you don't remember, it's okay. I know the hypotenuse, so I have to subtract to get a smaller side. I would do 13 squared minus 12 squared, and you'd end up getting 5. Just as a time saver. Let's look at this one. This is a 3, 4, 5. Now look at this one. Is this a 3, 4, 5?
No.
No, I would have to do the Pythagorean theorem. I don't know the hypotenuse, so would I add or subtract under the square root? Add because I need a longer side. So 5 squared plus 4 squared under the square root. And so I would get 5 squared plus 4 squared. I would get radical 41 or 6.4. Okay, so Pythagorean triple, non-zero whole numbers that satisfy the equation a squared plus b squared equals c squared. So I have those triples up there. I think it's fun on the assignment going, oh wait, that's a 3, 4, 5, and not having to do the work. My favorite is the 5, 12, 13. It's on your test. That's my favorite. I don't know why. Okay, so we can also use the Pythagorean theorem to decide whether a triangle is acute, obtuse, or right. So if c squared equals a squared plus b squared, it is a right triangle. But if c squared happens to be bigger than a squared plus b squared, it will be obtuse. I just remember bigger, obtuse. If c squared happens to be smaller than a squared plus b squared, it's acute. So you're going to be given 3 sides, and you have to decide if it's right, obtuse, or acute. So let's look. So I've got these 3 sides. First of all, which of these 3 sides would be the hypotenuse? Would be C. 21, biggest side. So what I would do in my calculator is do 21 squared first. So I'm going to do my 21 squared. Keep that in the calculator because then I have to compare that to a squared plus b squared. So if it's equal, it's right. If the c squared is bigger, obtuse. If the c squared is smaller, acute. So I'm going to compare that to 15 squared plus 8 squared. So 15 squared plus 8 squared. Okay, so the c squared is bigger, obtuse. Yes. Does that make sense? Maybe a little? Okay. Which one of these numbers would be our c? 28. So that's what I do. I just start with the c squared first. 28 squared, put it in my calculator. Then I'm going to compare that to a squared plus b squared. So 20 squared plus 21 squared. So the c squared is smaller, so it would be acute. Yeah. Acute. All right, which one of these numbers would be the c squared?
0.6.
0.6. So I could do 0.6 squared, and then I'm going to compare that to 0.3 squared plus 0.4 squared. 0.3 squared plus 0.4 squared. So the c squared is obtuse. Okay. Hey, look at this. That's a 3, 4, 5.
Yo.
So since it's a triple,
It's right.
it's going to be right. But let me show you, if you didn't recognize that, the 5 would be my c. So I would do 5 squared,
25.
and then 3 squared plus 4 squared. And they're the same, so it's right. Okay, let's look at one more with these radicals. Did you know that if you take the square root of 11 and square it, that the squaring and the square root, it's like they cancel each other out. So it would just be 11. Did you guys know that? And if I take the square root of 7 and square it, the square and the square root, they cancel each other out, so it would just be 7. Okay, so I've got my biggest side. Oh, you may not even know that. If you're looking at this, do you know what your biggest side would be?
No.
You might think it's square root of 11, right? Let's see. Square root 11, hit enter, toggle it. That's really only 3.3. Does that make sense? So it's really not going to be your biggest side. So your biggest side is going to be 4. So if I do 4 squared in the calculator, now if I do radical 11 squared plus radical 7 squared, you have to put the radical 11 in parentheses before you square it. Oh, whoops. Radical 11, tab out, squared, or you can just remember that radical 11 squared is really just 11. And then plus, because this is taking forever, radical 7 squared. So it's really going to be 18. Yeah, look. Because radical 11 squared is really 11. Right? Okay. Anyway, the c squared is smaller, so what would that be?
Acute.
Acute, yeah. Acute. Okay, so if the c squared's bigger, obtuse. If c squared's smaller, acute. If they're equal, it's right. All right. Last but not least, you will have a couple of area problems. Did you know the area of a triangle is 1/2 base times height? Okay, so I know my base, like on this triangle, is 20. What I don't know is my height. So I'm going to have to use the Pythagorean Theorem to find my height. Since these two sides are equal, this height is going to cut the bottom in half. And that's how all your problems will be today. So if this entire base is 20, this little piece right here would be 10. Are you okay with that?
Mm-hmm.
So in order to use the Pythagorean Theorem, I need a right triangle. I know the hypotenuse. Would I add or subtract? Subtract. I need a smaller side. Always do the biggest side first. 12 squared minus 10 squared. So 12 squared minus 10 squared is 6.6. So my height would be 6.6. Now I can do 1/2 base. What's my base? 20 times my height, 6.6. Are we good? So I'm just going to keep that number, 6.6, in my calculator times 20, and then divide by 2. I got 66.3. Okay, so let's look at this one. So this entire base is 10, which makes this piece 5. I know the hypotenuse. Would I add or subtract?
Subtract.
10 squared minus 5 squared. 10 squared minus 5 squared. 5 radical 3, which is 8.66. So now 1/2 base. What's my base? 10 times my height. So 8.66 times 10. And then divide by 2. 43.3 is my area. Okay, so if you know the hypotenuse, you have to subtract because we need a smaller side under the square root. If you don't know, add under the square root. Okay, those triples are my favorite. There's the 3, 4, 5, 5, 12, 13, 7, 24, 25, and 8, 15, 17. So those are some. What did 0 say to 8? Nice stuff. And then I've got my right triangle that's having a baby. It says he's too big. We need to perform a square root of a squared plus b squared. Do you know what that is?
C section.
C section. Yeah, C section. Okay, is your assignment unlocked?
Yeah.
Okay, I thought this was kind of cute too. Did I catch you at a bad time? Yeah. Okay, so a set of three positive integers, a, b, and c, that satisfy the equation c squared equals a squared plus b squared is called a Pythagorean. Okay, hang on. Hang on. So Pythagorean triple. Can you guys spell it?
No.
Pythagorean triple.
It's on question 2. Just look at question
Oh.
2.
Well, Pythagorean Theorem is on question 2, yeah.
Everybody knows.
Pythagorean triple.
Is it cap?
No cap. I don't think it matters. Don't do all caps.
Okay.
Okay, so number 2 is a triple. It's my favorite triple. It's a 5,
12,
12, 13. So, hey, you didn't even have to do any work. It's a 5, 12, 13.
Yes.
Number 3 is also a triple. It's just kind of hard to see. So this point is located at 5, 12, which means I go to the right 5 and up 12. So it's a 5, 12.
13.
The radius would be 13, yeah.
Get in there.
130.
I like looking for the, so this is also a 5, 12. Yay! Doesn't it make it more fun to find the triples? I don't know if that's a triple or not. So you may have to actually do the Pythagorean theorem. I don't know the hypotenuse, so would I add or subtract? 56 squared plus 33 squared, and this order doesn't matter. You can do 33 squared plus 56 squared, it doesn't matter. It might be a triple. I don't know. All right. If you know the hypotenuse, you subtract. But I also know that this is a triple. Do you guys know what number 8 would be?
No.
3, 5, 4.
4.
So it's a 3 something 5. What is it?
3, 4, 5.
3, 4, 5. So what would x be?
40.
40. Good. Okay. But if you know the hypotenuse, you would subtract. If you don't know, you add. If you know it, you subtract. Let's see. Scroll to number 18 just really quick. I just want to make sure you remember what those slashy marks mean.
They're equal.
They're equal. So if this over here is 6, guess what this is?
6.
6. You do not know the hypotenuse, so would you add or subtract? Add. 6 squared plus 3 squared. Yeah. So look for those slashy marks. Number 19 is the same way. Those would be 11. So the slashy marks mean they're equal. Numbers 22, 23, and 24, you're doing the area. And then 25, you have to decide whether the triangle is acute, obtuse, or right. Do you remember how to do those? Start with the C in the calculator, the biggest side, and then compare to a squared plus b squared. If c squared is, if it's equal, it's right. If c squared is bigger, obtuse. If it's smaller, acute. So, if you have questions, just let me or Mr. H know. We're doing Pythagorean Theorem again tomorrow and Friday. Another tennis thing?
More tennis. Come on.